अस्सलाम वालेकुम। तो ये है हमारे पास एक प्रोग्राम है सिंपल सा सेपन के लिए। तो ये प्रोग्राम क्या करेगा कि ए में 3H को डालेगा और फिर क्या करेगा कि इसके साथ 6H को ऐड करेगा, 6H, और फिर इसका जो रिज़ल्ट है वो हमारे पास डिस्प्ले होगा। तो इसके लिए असम्बली जो लैंग्वेज में प्रोग्राम वो इस तरह होगा। तो हमारे पास ये रैम का एड्रेस है और ये रैम का डेटा पार्ट है। तो इसमें हम इस तरह ये लिखेंगे LDA EH। तो EH हमारे पास क्या है, एड्रेस है, यहाँ पे EH, और यहाँ पे FH, यहाँ पे हमने जो वैल्यू हम डाल रहे हैं इसमें वो हमने यहाँ पे स्टोर की हुई है 3H है, 3 एंड 6। तो यहाँ पे हम क्या कर रहे हैं ऊपर कि लोड एक्यूमुलेटर विद दिस डेटा एंड आफ्टर दैट ऐड विद इट दिस डेटा विच इज़ 6। तो हमारे पास रिजल्ट कैलकुलेट होगा, फिर हम उसको क्या करेंगे, आउट डिस्प्ले कर देंगे और उसके बाद हॉल्ट है। तो ये रैम का एड्रेस है 0 to F16 बाइट हमारे पास रैम है। तो ये है असम्बली प्रोग्राम जो है हमारे पास, इसका असम्बली H, लेट मी टू मेक इट H, ओके। तो इसको मैंने हैंड असम्बल्ड किया है और फिर हमारे पास मैंने एक हेक्स फाइल इससे जनरेट किया है। ये हमारे पास है इसका हेक्स फाइल। तो ये असल में वो हेक्स फाइल है, जब आप इसको हैंड सिंबल करेंगे तो हमारे पास ये क्या है, 0 इज़ अपकोड फॉर LDA and E is the address where we have stored. So this one would be address. Now we will upload this into ROM. And the second address we have 01, and 01 we have 1F. 1 is the code for add and F is the address for 3. And then we have E. E is the code for halt, and for 0 it might be 0 or 1, we don't care about it. It might be any value. And on fourth address 03H, 0 1 2 3. On third on fourth address, you may say if you are starting from 1. On fourth location we have F, which is a code for halt, and then we have 0, it might be 0 1 2 3 up to F. This is a don't care nibble, the lower nibble with the halt and out instruction, it is don't care. And then I have filled all the rest of addresses with 0. So this is how I have written this program. So I will do what now, I will store this file, this program, with extension of bin binary. So I have done already that, and I got a file like this program 1.bin. So now I will go to Proteus. I have the Proteus over here, and I will go to, I have given the name Peshawar version SAP-1 because it is a little bit different from SAP-1. It will execute all instruction of SAP-1, but with the time inshallah I will update it, and probably it will have more instruction to be deal with. So now I have, where I gone, yeah, this is, so I had done, it includes some features in it, like I can program it through ROM. I will upload that code to this ROM. So what I will do, that I will right click over here and I will come, sorry, not here, here, yes. So now you can see here I will upload that file to this ROM. This file is program1.bin. You can access that by this looking you can go like this, go to placer, go to parent folder, main folder, you first go to stop, after that select Proteus project and access the file which where you have stored the program 1 dot program 1.bin. So here I think in programs program 1, so here it has been linked, okay. But now you have to take care, here you have to place after bin, here type comma, after that ASCHEX. ASC hex. Now store it. So that file will be uploaded to this room. So now what I have done, that before running the computer we have to upload the program to ROM, to RAM, sorry, to RAM of the computer. You can do that by two ways. One on this which I am doing, and then with the old way, which is in the book. What they have done, that they are just manually they are programming the computer by dip switches are simply logic states like this. This is a logic state button 1 and 0, but I will upload through this way. So what I have done, that I have connected the output of this ROM to the RAM of the, or the data lines of the ROM to the, where is that, yeah, here is the RAM. I have connected that with this RAM, and I have connected to the address lines of the ROM with this uh, RAM addresses, and I have provided here a counter which counts from 0 to 16. So basically what it will do, before running the program, we have to transfer or load the program from the ROM to the RAM. So how we can do that? First we will set the address 0h on the ROM and also on the RAM. After that what we will do, that we will give a write signal to the RAM, so the data of the ROM will be transferred to the respective address on the RAM. After that we will increment the ROM and increment the address to 1, and we will do the same thing, and we will go until we have reached the last address. So I have made this circuitry, a little circuitry for it, and when we when we complete this process, so it means that here we will have 1 1 1 and 1. So it means that we have completed our programming. 16 bytes I have written. After that the current counter will increment to 10000. So at this stage what will happen, that it will stop incrementing further. I have made some logic for that, and also it will show a status signal that all 16 bytes have been programmed, and their status signal will be displayed over here with us. This is that status signal. So now let me to simulate the system and load the program. After that we will, so yes, we have started. So first let me to go to where, yes, first let me to go to program mode. So I will apply one over here, and now it gone to program mode. Now what we will do, that I will toggle this switch load program. So you can see the program have been loaded from the ROM to the RAM, and you can see that the status is 1. It means that the program is loaded. Now I will go to, but before going to run mode, let me to turn off the clock to manual mode. So in manual mode what I can do, that I can skip through the program just by single clock pulse manually. So now I'll come back to run mode, and you can see now, so this is the T state. Here you can see this is T state. So on the first T state, on the T state 1, what would happen? Oh, no, sorry. First let me to reset the computer. Yes, you have to reset the computer after loading the program. So reset the computer. Program is present in the ROM, in the RAM of the computer now. Now you can see that we have two signal: enable program counter and load MAR. So on the first clock pulse, what would happen? The content of the RAM would come to memory address register. So this is the manual clock. Yes, you can see. So now 00 is present in program counter, so that came to ROM, MAR, sorry, MAR. And you can see that on the first address, whatever the value we have stored on the first address, or means 0 address, the first location, that is present over here. You can see on the RAM. Now the second T state. Now let me to complete this pulse. So 1 and 0 is a complete cycle. So Now we went to second state. This is an increment state, so you can see that increment PC. Now with I will give a second 1 and 0. The program counter has been incremented to 1 from 0 to 1. Now you can see that now we have on third state. And third state, what we say that load RAM and enable RAM, sorry, enable RAM and load instruction register mean put the data of the RAM on the W bus and give a load signal to instruction register. Now whenever we will give a clock pulse, that content from the RAM would come to instruction register. Now you can see, yes. So on fourth state, what we would have, this is the LDA command, remember the first command. Now we would have now LDMAR and enable IR. So from these, from the upper nibble, the computer will know what the instruction is. So the three states, we know that for each instruction, the fetch cycle means the first three states are the same. We have deal with that in our course. And the second, the sorry, the lower nibble. Now where it would go? It would go to memory address register now. So and this pulse, what would happen? You can see the lower nibble gone to memory address register. So this is basically the address of the data, in which we are interested to move that to a accumulator. Now we have two signal, load MAR. Yes, we have done with that. Now let me complete this. So now we have Unti5. So Unti5 we have enable RAM, means that put the content of the RAM on the bus, W bus, and load A. So now on RAM what we have 6H, you can see this is 6. So now at this clock what would happen? The content of the RAM would go to A, and we will complete our first instruction. So this is LDA we have completed. And the 60 state is a nope. So means that we don't want to do anything with this instruction. So I have made some logic, such a logic that whenever such state comes, automatically the program counter, sorry, the T states will reset, and the next instruction will start execution, means the next instruction T states T1, T2, and so on. Now we have, I will go now something you may say with speed. You can see I will go a little bit fast now and just observe the things. Now we have unaired B. So unaired B, now this is, we have B register just above the output register. This is the B register. So unaired B, the content of the RAM will go to, sorry, content of the RAM will go to B register. Now you can see the content of the RAM, the content of the address 15H. Now 15H, sorry, not FH. So on the 16th location, contents came to B register. Already we have the 6 on the A register, so its sum became 9. And you can see that whenever add instruction completes the content which we had in the adder or subtractor, so at the end that will again go to A register. So now you can see that we have 9, this is 91001 an accumulator. So the add instruction also is completed. Now we have out instruction. So that now we have out instruction, and so in out the accumulator content or the A register content will go to bus and then to out register. Now we can see, yeah, we have done out instruction. We loaded the content of the 15th address, 15th, sorry, the EH, the 15th location